Let's take a look at another example of a two-pointer based approach to iteration. Now this one's a little bit different from the first one that we saw, but the same sort of idea is going to apply, so we'll see generally the pattern that's shown here. The idea of this problem is it's known as the two-sum sorted problem. Basically, as an input, we're going to get a sorted array of integers, which we'll call s, and a target to reach, which is t. And our goal is to output the index of two numbers that add to reach our target inside of the sorted array. So in this example here, our goal is to get to the number 9 using this sorted array here. If we take a look at this, 2 and 7 would add up to give us 9. So the return index would be 0 and 1 in this example here. In this one here, the target is -1, so the two things that we would add together are these two indexes here. That would give us our target of -1. So that'd be an example. A few main notes about this problem. The first is that the value that we're looking to sum to will always be possible to sum to in our array. So what I mean by that is you'll never get an array that has no sort of two numbers that sum to our target. There's always going to be two numbers that sum up to our target. So that's the first thing to keep in mind. The second thing that I'll keep in mind is that often when you see this problem, it asks you to return things as if you had a one-indexed array for whatever reason. So for this particular approach, we'll do that same sort of thing, since I know that that's what a lot of people are looking to do with this kind of problem. But just know that the zero-indexed approach is the same thing. We just won't add 1 to the return result. So either one you can use from this sort of approach. Let's talk a bit about how we're going to iterate through this. So there's a few different approaches that we can use for this sort of process when we think about this idea of iterating through this array to find this sum. One of the first things that we could do is we could start at the beginning of the array, and we could just try to add it to every other value. We could go to the next value in the array and try to add it to everything. We could continue through that process until we reach the end of the array or we find what we're looking for. That'd be one way to approach it, but when you look at that iteration, in the worst case, we're going to have to iterate the whole array twice, which would give us like an n squared time complexity. So that's not really ideal. We could do a bit better than that. And the way that we're going to do that is using the two-pointer approach. And you have to think a little bit about how this problem works in maybe a bit more of an abstract way. Consider the idea that the array that's input is sorted, right? That's really important in this sort of problem. If you were to add the value that is the rightmost value to the value that's the leftmost value, you would get some sort of sum. And the question that I'll ask you is, if this sum were bigger than our target, what would you need to change in order to get us closer to the target? The answer would be that if the value is bigger, we could move the rightmost value over 1 to the left, and that sum would always be smaller because the value would be decreasing, right? Now, conversely, if we wanted to get a value that was bigger, then we could move the left-hand side over to the right one. That would in turn give us a sum that is always bigger since the value would be increasing. And this is the general idea of the two-pointer problem. We're going to start our pointers on both sides of the array, so one on the right-hand side, one on the left-hand side, much like our previous example. What we're going to do is we're going to add those two numbers together, and we're going to take a look at that sum. If the sum is bigger than our target, we'll move the right pointer to the left one. Otherwise, if the sum is bigger, we'll move the pointer on the left-hand side over to the right one. Continue this process until we reach the target that we are searching for. So if we were doing this in this example here, we would start with 2 and 15, which would give us 17. That's bigger than 9, so we'll move the 15 pointer over to 11. That would give us 2 and 11, which is 13, which is still bigger, so we move this over one more time. We get 2 and 7, which is 9. That's exactly what we're searching for. Do you see how that takes less iterations generally than the actual approach of having to iterate the whole array multiple times, right? You see that we only have one iteration in this case, and like before, we only have to do really half of the array, so we get this kind of n over 2 efficiency that's nice and clean. The implementation for this is also very clean. It's not very much code at all, so let me show you exactly what that looks like. I'm going to create a function called toSum. And the toSum function is going to take in a set of numbers, like I said before, as well as a target value. We're going to start the left at index 0, like I said before, and the right at the length of the numbers, -1, which would be the right-hand side in this case. And then all we're going to do is we're just going to iterate while left is less than right, just like we did last time, right? We're going to find our total, which is going to be the numbers at the left plus the numbers at the right, okay? If the total is equal to the target, well, then we're done. And we can just return right here. Like I said before, we're often looking for these as a one-indexed value, so we add 1 to them here. If you weren't doing that, if you were just looking for the actual indexes themselves, you just get rid of this +1, you got the right answer, right? On the else here, the first else will be if the total is bigger than the target, as I mentioned, we'll take the right-hand pointer and we'll move it over 1, right? And then otherwise, this would mean that the total is going to be less than the target. We're going to take the left pointer and add 1 to it. And that's all there is to this. So nice and easy, right? All we're really doing is just moving to get the sum to be bigger or smaller. There's a few patterns that I want you to pick up on here, okay? The first pattern is that when we iterate using a 2-pointer approach, this is usually our stopping condition, that the left is not less than the right, right? So the left and right pass each other or they meet each other in the middle, right? That's almost always our stopping condition in this kind of iteration. The second pattern I want you to start to realize is when we're using this 2-pointer approach, it should start to become a bit more clear now. If we want to be able to keep track of two things at the same time, in this case, we're literally keeping track of two values to sum together. In the palindrome example, we were keeping track of the string forwards and the string backwards. In those sorts of cases, we often want to take a look at this 2-pointer approach as a possible approach to our problem itself. So there's just some things that I want you to keep in mind as you're looking at this implementation. As a final thing here, let's just run this code and see if it actually works. Just make sure I didn't make any sort of mistakes as I implemented this. So we'll do a 2-sum, and I'll grab some of our examples here. So this 2, 7, 11, and 15, right? So in this example here, just get this nice and proper. If we were looking for the value 9 inside of this, we know what we're generally looking for in that terms, right? So we'll say 2sum.py. We get index 1 and 2. Remember, one index value, so that'd be this and this here. Now we could do a few other examples, right? Like what about 7 and 11 would make 18, right? So we could check that and see what ends up happening. We get 2 and 3, index 2, and index 3, right? So exactly as we were expecting in these sorts of outputs. So that gives you a general idea of how we can solve another 2-pointer approach problem. Again, as our final sort of analysis here, when we're taking a look at this, since the left and right are generally moving up towards each other, we're going to see overall something that looks like about O of n for our algorithm efficiency, right? Generally, this is going to be about linear growth, so it's a fairly good solution to this sort of problem. You'll see that if this array isn't sorted, we have to take a slightly different approach, and we'll take a look at that in future videos as well. But for this approach, this is a pretty good solution to our problem. So that gives you another cool example of a 2-pointer based approach iteration on an array. So thanks so much for watching, and I'll see you in the next video.